I'm not seeing my ability to share this, share slides. There we go. Okay. It's now share slides, but I think we're good. Okay. So we are starting now because I did a bad job of queue management. We have way too many slides. Mike, I'm going to ask you to like speak much less than you thought you were going to. Okay. So anyway, welcome to PQUIP, and we've got sort of the normal note well. All of you already read this because you agreed to it when you signed up. And then this is the let's treat each other with, you know, kindness and consideration, which is not always an automatic thing in the cryptography community. So let's work a little bit harder on that. I mean, we've done pretty well in the working group, but that doesn't mean we're always going to. So let's try. So here are the meeting tips that hopefully you've seen. Absolutely make sure that you've signed in to Metaco. Either, I guess now it would be through the data tracker. If you haven't, or if you didn't see the QR code, that's how we know we will get an appropriately sized room. Quick agenda overview, which is that I'll do a document status, talk about a few things that are happening this week that aren't this working group that are relevant. Then we're going to have presentations on 2 potential documents which are might be coming into the working group. And then we've got a bunch of other presentations. And when I say a bunch, I mean a larger number than I thought we were going to. And I will get you out of here at 6:30. So let's jump right into the current document status. For those of you who aren't really like following the mailing list and you're just sort of touristing here, we basically have gone through our queue of documents. The terminology document is now in the RFC editor's queue. I'm sorry, terminology for hybrid schemes is in the RFC editor's queue. The hybrid signature spectrums document, which is one that explains what are the kinds of things that you might be doing with hybrid signatures, is in IETF last call for another couple of weeks. We've gotten almost no comments on it. We just got one actually in the last hour or so from one of the reviewers. If you are here and you're not a regular and you're wondering how to participate, doing a review of that document for IETF last call would be greatly appreciated. And then we have the post-quantum cryptography for engineers document, which is one that has been around for a zillion years. That went through working group last call. AD has given, AD Paul, that Paul, not this Paul, has given the authors some comment. We're waiting for those to be included, and then at some point he will send it off to IETF last call as well. So those are the 3 documents that we have in our charter. What we are going to discuss next are some ones that we might or might not adopt. But for now, the things that we've said we're going to do, we have pretty much done, with the exception of the last one, where we need to do another round before it goes into IETF last call. So before we do that, let's do a quick overview of, now how do I share, stop sharing? I'm going to have to do this manually each time. Yuck. Okay. So I'm going to ask you to be faster than you thought you were going to be.
Oh, you're going to be much faster.
Okay.
Hi, everyone. My name is Jean-Pierre Fizet. I'm presenting today because John Gray is indisposed. I've joined the group, this group about a couple of months ago. This was my first hackathon, so I'm really like not qualified to make this presentation. However, the group gathers basically they meet every 2 weeks, and they're concerned about all those basically draft that you see in front of you. And what it is, it's a group that basically work together and try to figure out the interoperability between different vendors and crypto libraries. So we can go to the next one. So what has been done so far? So they're iterating through a number of versions of the way that they show the results from one to the next. And so this weekend we worked on this. We worked at adding the new key formats for MLDSA and MLChem. They've added artifacts for SLHDSA. And so most of the team members are not here. They're 12 hours away from here. So 6 different implementation worked on MLDSA, and we all start testing against each other. Composite signatures, there's a new draft about that. And so it's posted. And there was like much discussion onto the ASN1 format. So we'll go to the next one.
Oh, this works.
This works? Switch one.
Perfect.
All right. So what got done as well, so a pure Rust implementation was submitted for MLDSA, MLChem, and SLHDSA. OpenSSL, they've been like quite active, and so they've looked into the RFC that has to do with the one symmetric key, asymmetric key format, and they're also doing the CMS chem recipient info. They've done their own implementation of MLDSA, MLChem, SLHDSA. So all that was working yesterday. And we're looking at adding more granularity as far as how we report the test between the different implementation. What we have learned, the extended output format shake is giving difficulty on the implementation. Also, the draft, the RFC 96/2029 does not give mandatory implementation, and so it leaves the implementer a little bit out as to figure out what they're going to actually put in there. The most difficult thing yesterday was to realize that, you know, for some people, they're middle of the night working with us, and so that was quite a challenge. This is the team members. You're going to see my name as a first timer, and so I'm great to be standing in front of you guys. These are pictures from previous ones, and that's it. I'm done. Was that fast enough?
Yes, it was.
Perfect. Thank you.
So just briefly, again, this is the signatures. Do note one of the things he said on almost the first slide, which is they're meeting every 2 weeks, not just at the hackathons here. So if this is of interest to you, there's plenty of info on how to find them. We have probably one of the most active hackathon or hackathon equivalents going on here. So let me now, you don't have slides.
No,
so
and I think I just start to save time. So
Yes, please.
Paul asked me to give a short summary of the PQC public side meeting. I think it was very well visited. There was over 100 people from industry, governments, and academia, and both IETF people and government people thanked me. So I think everybody was happy. It was a good dialogue. The summary of the meeting was the European Union is working on timelines, will be published soon. Technical specification on algorithm on the EU level will come next year. But a lot of the European member states already have specification. There are also some other organizations like SOGIS with 7 countries that have recommendations. The UK presented, they have recommendation. They basically recommend the NIST algorithms. All security levels are fine. They are fine with hybrids, but they prefer standalone would be my summary. Then UK pointed out that they don't see any impact on symmetric crypto, no recommendation to double keys. Then there was discussion about FrodoChem. Again, the European, on the EU level, there is no recommendation on algorithms yet. BSA stated that they are and they will still support FrodoChem in the future. There was a discussion, nobody could point out any member state in the EU that does not recommend MLChem and MLDSL and SLHCSA. So I think anonymous alignment on this, maybe a different security levels, and then some countries also recommend classic McAllis and FrodoChem. NIST said that FNDSA will come soon, and they have standardized HQC. Canada presented and say they are partnering with NIST on certification and are aligning very much with NIST regarding recommendations. Then there was discussion of PQC with some countries saying might be defense in depth in the future, and some countries, for example, Sweden, saying it's not even that, the only use case is if you don't need security. Then there was discussion about cost. Who will pay? How do I motivate this? No real answer. Then there was debate between cryptographers. They were arguing against hybrid, and Tanja Lange arguing for hybrids. And Germany supporting Tanja, and UK supporting Deidre. Yes. And then European Union said they will go into recommendation for different sectors, but like water infrastructure, schools and so on will all get different recommendations. There was a question about firmware updates, but no clear answer from anybody.
So you will send these notes to the mailing list?
Yeah, and the meeting was recorded. So
very good.
I will, I don't know when and where it will be published, but
Right.
I will publish it and send a link to PQUIP.
Very good.
Yeah.
Thank you.
Thank you.
So that was the side meeting that happened just before this one. Oh, wait, didn't I have? Sorry, I thought I had. I'm sorry? I'm sorry? I do. I thought I wanted someone else and I was wrong. So you probably even want share slides, and here we go.
Let me just get started. I'm Tom Wiggers. I've presented on this a few times already, but we were quite busy and now we're a little bit less busy.
I think that'll work now.
It seems to actually work.
Yeah.
So yeah, stateful hash-based signature schemes. They have state. You need to be very careful with the state. If you mess up once, you're really screwed. But if you want to say do firmware signing, have a key that still is able to issue like software updates or something in 5 years, and 10 years, and 15 years, and 30 years, then it's really scary to have that key only in one place. So how do you reconcile that? That's sort of what we're trying to set out in this draft, not just like cryptographic details, but actually more of the operational stuff. How can you design a system that relies on stateful hash-based signature schemes and is reliable and secure, hopefully both. And that when you talk about this and you talk to people that, in no insult intended, but haven't really thought about this problem through, then they'll say things like, oh yeah, but I'll just divide time in epochs, and then I'll set up my HSM that it can only produce like a signature if like the new hour has started. Well, we have like fun content such as this part of the draft. And basically it starts with any time keeping based approach, yada, yada, yada. And then we have a list of 16 like must, should, etc., 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 because that's all the sort of things that you must get right. Also a very good way to cite the XKCDs about time zones and all that sort of stuff. We're at version 0.01 now. So since the last version, I added a little bit of text where someone prompted me about, yeah, when might these schemes be appropriate? So I added a little bit of that. And what has also happened since the last time is that NIST has actually realized that the way they specified their requirements made it very hard to deploy these sorts of schemes. So there's been discussion on their end and proposals from their end on relaxing it can only live in this one HSM, it needs to be generated in this HSM, it can never leave that HSM, because that made it a bit tough on people. And it's looking like this is going to go into a direction where you can do some sort of backup mechanism, export parts of your key, re-import that. And what I found interesting is that at that meeting, there was also a lot of discussion on, yeah, but then this starts to get scary. How do you solve this and that sort of thing? So even though NIST is seemingly going to relax a bunch of the backup requirements, maybe that means that there's even more responsibility and even more requirement to sort of think about how we can do that sort of thing. So yeah, that is my pitch. We have a document that has a bunch of things in there, but I think this room really might have a lot of people that have thought about scenarios that we haven't thought about, which is why I think it would be helpful to do this work here rather than just yeet it over the fence at the independent submissions or whatever.
So instead of having questions now here, what I think we should do is discuss the draft on the list for about another month and get, see if there's two things, see if there's interest, see if there's a lot to add to it or whatever. It sounds to me like it would be good, like you said, it would help NIST if we had sort of laid out all of this before they need to do their update.
That might help. I don't think that their work bites our work or vice versa. Right. I think they're complementary in many ways. Yep. Of course, we need to make sure that they don't bite.
Right.
But yeah, I think that it can help.
Okay. So my intention is to try to kick the list a bit more to discuss the draft. And then at the end of the discussion, we will have a question of a call for adoption. Make sure it fits in the charter, which I think it does, but also to see whether there are more than 2 or 3 people interested. If there are, that's great. And then we can move it as a working group document.
And maybe, yeah, discussion also means saying that you think this is worthwhile, I guess.
Right. Yeah.
Not just if you disagree or have anything explicit to add.
Yeah, exactly right. So we would do that after having what else is there to add and such. So do read the document if this is in your realm. If it's not in your realm, but it's in the realm of one of your coworkers, someone else who has to care about this, please hand this off. Remember, working group membership doesn't exist. It's a mailing list. We want to take contributions from as many useful people as we can. So if there are people who who would find this interested, they're already getting scared about not being able to copy off their keys and still be following this guidance, please pass this along to them. Thank you.
Thank you.
Okay. Tiru? Oh, hang on a sec. I need to. Yep, I believe that works.
Okay. Hello, everyone. I'm Thiru. I'll be talking about adapting HSMs for PQC. As we all know, HSMs are widely used for secure key management and cryptographic operations. Transitioning to PQC introduces challenges, especially for constrained HSMs. For instance, if you have MCUs integrated with cryptographic hardware modules directly on your SOC, constrained HSMs, especially with PQC, face several limitations, especially with regard to storage, memory, compute, and performance. So what we started this draft was when I started interacting with some of our HSM vendors, I realized that they care mostly about the certification, FIPS, and PKI certifications basically, but there are some other considerations they have not considered, and I thought, why not put them in a draft so that that makes it quite easy when you're talking to leverage constrained HSMs. So currently the scope of the draft is how do you optimize PQC integration in constrained HSMs? How do you optimize PQC signature algorithms and the PQC impact to HSM firmware updates and backup? Right. The next slide is about seed-based key generation. I think Mike is going to talk about all the work that's happened in LAMP's working group with regard to the challenges of whether to use seeds, whether to use expanded private keys or both. I think the working group has finally converged probably to use all of them, right? Right. And the challenge is like, we all know like PQC algorithms require large key sizes and constrained HSMs have limited storage capacity. Seed-based key generation is a promising approach, but has certain trade-offs. The key is if you're using seed, you can deterministically generate private keys, and that would significantly reduce the storage overhead. For instance, if you pick MLDSA 87, then the seeds just requires 32 bytes, whereas private key would be around 4K bytes. It enhances the scalability in HSMs with limited memory, but on the disadvantage side, it increases computational cost that every time you have to regenerate the public-private key pair. And the key generation computational efficiency differs from algorithm to algorithm. And the other challenge is if you destroy the seed, then there is no way to recover the seed because it's a one-way hash function. Then if you're dealing with seeds for long-term private keys versus ephemeral keys, then you also have to generate ephemeral key pairs from ephemeral seeds and destroy them after the cryptographic operation is performed, and like destroy the private key after the shared secret is generated and ensure like the seed doesn't get reused across different TLS sessions or algorithm suits. Right. The other challenge is, especially with the new algorithms, right? Like especially if you pick MLDSA, right? Transmitting the full message to HSM increases the overhead. So there are ways to send only the message digest instead of the full message. For instance, MLDSA has this API, external MU MLDSA, where the pre-hashing of the entire message could be done in the software module itself, and only the pre-hashed variant could be sent to HSM. So that would not cause any interoperable issues because it would work even with if the peer is implementing a pure version of it. So that makes it work that if you're doing running on constrained HSMs, you could pick that API, right, than the pure one. And as usual, all the firmware updates, right, including HSM, would have to be upgraded to support PQC signature schemes, which would be the stateful ones. More prefer to use SLHDSA than MLDSA because of its long-term security cryptographic stability. Yeah, and we wanted to add more details on some of the optimizations that could be done with regard to implementing some of these algorithms on constrained HSMs. But since this is a 0-0, we wanted to gauge whether there is enough interest to pursue this work. And we wanted to do more updates in the next few versions, but want to see like if people are interested in this, want to contribute to this, then we want to take this work forward.
So we've got about 5 minutes for Q&A on this. One of the things, so there's two sort of questions. One is, do we want to adopt this since it's mostly just advisory for telling people if they're going to be dealing with HSMs? But the other is, are we giving good advice? So Mike Q is open.
Hello, Scott.
Scott?
Hello. Is this on? Okay.
Yep.
Scott Fleur, Cisco Systems. The obvious question is, this is actually within the IETF charter. Is it the business of the IETF to tell hardware manufacturers what to do? That's another question for the working group, not necessarily for you. Thanks.
Right. So that would be part of the do we adopt it question. Yep.
Richard Barnes, Cisco. This doesn't seem in the scope of the IETF or this working group.
Okay. Jean-Pierre?
Jean-Pierre Fizet. When I'm not here, I'm an HSM developer and implementer and manufacturer. The last thing I need is one more document that restrict what I can do and figure out all the jurisdiction I have to do. However, I think there's an opportunity here. Just before this meeting, the governments are asking themselves what makes things PQC and stuff like that. I've already talked to Tiru about it. I think this is a great opportunity to capture together what makes an HSM quantum safe, what makes equipment quantum safe, so that, you know, as the government stakeholders are looking at this, they now have guidelines as to how to select, you know, the equipment and whatever the question to ask to their manufacturers. So I think there might be some value there. Thanks.
Thank you. Deirdre?
Hi, Deirdre from Sandbox. I think this is valuable. I support adoption. That's it.
Thank you. Okay, so we will definitely do more of this on the list. Again, I think what we want to start with is what needs to be added or subtracted on the document. And that might include toning down musts and shoulds and turning it into advice, or it might be turning the knob the other way and making it more definitive. So my feeling is that there'll be a lot longer discussion before we get to should this be adopted in the working group,
Sure.
but there will still be rounds then for you to.
Yeah, intentionally we kept it as an informational,
Right.
just for helping people when they're leveraging constrained HSM.
Right.
So this is not like a mandatory one that they have to do, but a guidance if you're implementing HSMs or wanting to leverage HSMs, what are the factors to consider?
Great, great, thank you. Okay. Take you out of the queue and remove the slide clicker. Yes, I do want to take it back. We stop slides, we start slides.
Well, Paul's getting things handed over, just to be a little more constructive than my last.
I'm
comment.
sorry, can you?
Yeah, so it's just to be a little more constructive while you're getting things arranged. Like, I think that this is more properly a matter, this last doc, more properly a matter for the OASIS, like PKCS 11.
Actually, can you undo your yeah.
Yeah, PKCS 11 TC at OASIS, right? That manages the HSM interface. It seems like an issue for them.
Right, okay, yeah, so it might take us sharing with others on that. Okay, so now we have a remote presentation with Britta. And Britta, you have 15 minutes.
Oh, fantastic. I've gained time. All right, so this is actually talking about efficiency, which is a fantastic topic considering this working group theme. And I want to share something that is going on within one of our working groups over in the MLS working group and allow people who might not be tracking that to potentially gain from what's going on over there. Next slide. So short version is post-quantum, of course, can be very costly. And normally we say hybrid is going to be even more costly, especially if you're talking about, for example, bandwidth constraints. And we've all heard the arguments for why someone might not want to do post-quantum in a given setting if the device is very lightweight, and we make an argument, does the quantum attacker really go after that device? Of course, if we're doing security for that device today, we need to consider it in the future. So post-quantum is in the roadmap. But how to do that efficiency, or with efficiency, is the question. So next slide. I'm going to walk through basically what's happening in the MLS working group in one draft over there for efficiency. And it's a very simple idea. So here's a case. You're dealing with a stateful protocol. It's a continuous key agreement protocol. And you have the classic version, which might be using DHChem, for example, where you have your handshake, and because it's a continuous key agreement, you update your key material through chems. So the natural correspondence here is that in a post-quantum session, you would then replace the chem with ML-chem. So quite straightforward. Now, if we start saying how to do this efficiently, that looks like it's going to add up over time. And in fact, this applies again to any working group in existence that's dealing with handshakes, because if you're replacing every handshake with a post-quantum, it also will add up. But that part of it being a stateful protocol is what we're going to leverage. So next slide. So there's actually a third option here. And again, this is a very simple idea. So instead of just going straight up PQ, you could actually do 2 parallel sessions. So this is a type of hybrid mode, you could say, where you're going to run a standard session and a post-quantum session in parallel with the same membership. And the instantiation here is going to take a PSK derived from the post-quantum session and inject it into the standard session. So you're not sending messages in both groups or in both sessions. You're only sending those in the standard session. And the post-quantum session is strictly in a key management sense. So again, PSKs are being derived from one and injected into the other. Now, here's the benefit. That PSK is, of course, going to enter the key schedule. And that, since it is a stateful protocol, is going to be a persistent key schedule, which means you can periodically, again, do post-quantum updates to your key material. But those post-quantum updates do not have to be at the same frequency anymore as your standard updates. In fact, you can have very much of a turn dial control about how frequently you do the post-quantum updates. But since the PSK is entering that key stream, and this is going to be an AAD cipher suite, of course, you get both post-quantum confidentiality as well as authenticity. And then the question might be, well, what about entity authenticity? Well, if you have the 2 sessions, you could, in fact, have your post-quantum session run with post-quantum identities or credentials. And so you're having those updates authenticated with post-quantum signatures. But again, that is whenever you want to do the post-quantum update. And so you can amortize that cost essentially over a longer period of time. So you have a lot of flexibility here. Next slide. Here in the MLS sense, we broke this into a couple, I'll say, separation definitions. So again, what we call a partial update, which is just your standard one. And then the full update is when you do a post-quantum and standard at the same time. Next slide. We also mentioned doing the authenticity. We can break these into different mode styles. So you can do it where it's confidentiality. This is the classic case of considering harvest now, decrypt later, where you're only doing post-quantum chems but no signatures. And then you can do it with the authenticity, where you're also doing the post-quantum signatures. Now, the signatures happen on messages again. So these signatures will cover updates, for example, and also the messages themselves. But messages, actual data, is being sent in the standard or traditional session, which means you're not getting post-quantum non-repudiation. That's the one point that you do not achieve in this. You do get post-quantum authentication. Now, what does that really mean with non-repudiation? Well, because you have post-quantum authentication all the way from the entity down to the data in the AAD stream, you're not getting the post-quantum signature on the data itself. But an attacker would have to essentially be an inside group member with a quantum computer that is trying to say that you sent the message instead of them sending the message. So it already has authentication against any external attacker, but it would be an inside group member that you'd be concerned about. So it's a little bit of a niche scenario where you'd actually be concerned about non-repudiation for those sorts of messages. Next slide. Now, the flexibility here, again, you have a lot of options, and you can vary these sorts of things widely by use case. You have a very simple version where you only do post-quantum instantiation once, and the rest of the time it's traditional. So essentially, it's a quantum sense. You have one long-lived key from that one instantiation. But then you can have updates more frequently, and those could be either for confidentiality or the confidentiality plus authenticity. And what you get in terms of authentication and PCS and forward secrecy vary also across which combinations you're looking at. Now, again, the real benefit coming out of this is that, or the real thing that I should say is enabling all of this is the fact that this is a stateful session. So if you're talking about web connections where you've got lots and lots of clients connecting to a server and you really don't want to maintain state, it's not going to be great. However, if you have cases where similar clients are reconnecting to the same server or devices to other devices and so forth. So for protocol uses today, where you're not worried about memory overload, you actually have a lot of opportunity for using that statefulness to amortize the cost of doing the post-quantum. Next slide. So how much amortization? It varies a lot, but we had some tests here, and this is from Noah Green, who did this as part of his master's thesis. There's probably some lurking variables, so I'll give some variance to the exact numbers. But you can see orders of magnitude here, differences. So versus doing a pure traditional session or a pure post-quantum session, and as this varies by group size and so forth, you have this as just a few example categories of doing one post-quantum update per every 10 traditional updates or per 100 traditional updates and so on. Now, of course, today, if you're talking about traditional updates, we already know that key rotation should be fairly quick. We should not be tempted in a post-quantum sense to delay key rotation. That would be a bad idea on multiple fronts. But by combining these two, essentially what the attacker would have to do is they'd have to both be a quantum attacker and have access to the state in order to reduce this to a sort of post-quantum only session equivalent. So you're really getting a lot of value out of having that hybrid in a sense of not just security, but efficiency. So on that, I'll take any questions.
Are there questions? Actually, so I've got one, Britta, which is how appropriate are these calculations for things that are not MLS or not even MLS-like? So like just a standard like TLS session or whatever.
Fantastic question. So this is comes down to, again, how stateful you want to be. There's no reason why we need to be saying TLS, for example, is classically a stateless protocol. We have looked at internet protocols as stateless for a reason, right? But many uses of TLS today, it doesn't need to be stateless. And we'll be actually discussing this at further depth in the Deep Space, or now Tip-Top working group later in the week for space communications. And it was also discussed in the DTN working group earlier today. So there's a lot of uses where, I'll say the Tip-Top one is actually looking at using QUIC, and so the discussion there will be how can you use something like this to get post-quantum, but with QUIC. So there's a lot of uses where we have protocols and we don't need it to be stateless necessarily. So if we revisit that concept, we can potentially get a lot better efficiency.
Great, thank you. Deirdre?
Hi, Deirdre from Sandbox IQ. Thank you for especially the benchmarks. Do you have benchmarks comparing whatever epochs you like for the different hybrids with using a hybrid cam inside of HPKE, such as X-Wing or one of the CFRG ones that have just landed? That would be really nice to see that difference, because this design has a lot of nice things about it, and especially the tunability, but also it's moving a little bit further away and has a lot of stuff to manage than just slotting in a hybrid cam into HPKE and you don't have to change anything else. So more benchmarks on that score would be nice to see. That's it.
Sure, definitely. And you can say, just as a concept analogy on this slide, obviously the benchmarks for those are going to be higher than your pure PQ version there. What we've already seen in the context of MLS is that if you're talking about doing X-Wing style combine or so forth, there can be a temptation, depending on your use case, to just delay those updates. So you're just updating a whole lot less, which of course we already know is a bad idea. That's why we did forward secrecy and PCS and all these great efforts to begin with. And so having longer delays to key updates isn't a great great case to be driving towards. Of course, as always, it depends on your use case. Some have great bandwidth and so forth and don't have to worry about any of this. But if you are in such a concerned case, then there's options.
Thank you. Tiru?
What happens after the transition from PQT hybrid to if someone wants to migrate to a pure scheme, right? All these performance benefits will go away, right? Eventually, let's say once traditional algorithms gets obsoleted, you will have to support pure PQ, right? In that case, eventually, if this is for purely performance benefits, eventually this will go away.
So this is actually a really good question about whether this would ever go away. Obviously, you can if you have if you deem you have sufficient bandwidth and so on. The nice part is these are just two parallel sessions, and you essentially stop using one of them. So there's a lot of ease to here, a lot of ease in composition of proof and so forth of understanding the security. That said, you don't necessarily need to go away from this, and this could be potentially for some very lightweight scenarios a long-term solution. And we're certainly looking at it for some of our cases as being such.
Thanks.
John?
John Mattsson, Ericsson. Very nice. I think this have value, especially as you provide benchmark. I didn't understand exactly which variants of which security levels this was. But I think it could be value to test out different security levels of the algorithms also and see what properties, security level do you get then against different attack and security properties.
Oh yeah, thank you for pointing that out. I didn't write it on the slide. This should be 768.
Scott?
Scott Fleur, Cisco Systems. I'd like to point out that even if the traditional is completely broken, there's a real world crock. One thing you can replace maybe the traditional with an ML-Chem 512, and that still gives you some savings.
So, I see what you're saying. So to do a 2 post-quantum here, essentially, but one where it's much lighter weight. Yeah, the nice part is there's a lot of combinations that you could look at depending on what the concerns are.
Great. Thank you, Britta.
Absolutely.
And confirm. And you can have, that isn't working yet. You can have 15.
Oh, okay.
I think we're, yes, a whole 15, not even a partial 15. Actually, you can even go to 20.
I'm actually happy to use the time constraint and skip the details. They're in the thing for reference. I don't need to belabor them
Okay.
here.
Deirdre, you get plenty of time to beat us up.
Oh, good. Oh, and then maybe I'll use the whole time then.
Right.
Save Deirdre's mic.
I think I'm named in her slides more than you, so.
Yeah. Okay, I feel like I probably should have had a Ralph Wiggum thing that says, I'm a flame war. Okay, so there's some stickers floating around. I made stickers. They're good stickers. Okay, so this presentation is basically LAMPS has exploded. I think 0 human beings have read the entirety of the LAMPS thread for here, maybe except for Russ, who's a machine. I'm going to try and summarize for those who haven't followed all of it in the hopes that other working groups don't repeat the same thing. I'm trying to save time for everyone else by telling you we've done there, we've fought all these battles, don't repeat them. Does this clicker work? Yeah, it does. So the context here, this is an update on the keys versus seed private key thing. So if you read FIPS 203, FIPS 204, one possible interpretation of those documents is that both, if you want to export a private key from a thing, you can export it either as a fully expanded, semi-expanded matrix, or you can export it just as an RNG seed. and then that seed can be used to run keygen later. And it looks like both of those are allowed. Maybe. Some people have chosen to take a different interpretation of those documents under which they are not allowed. And this has led to gazoodles of confusion. So the relevant, seemingly some people can argue conflicting language is these following paragraphs, and the bolded points are the relevant ones. So section 6 says these internal functions, mlchem keygen _ internal, should not be made available to applications except for test purposes. But then there's this exceptions list in section 3.3 that, depending on how you want to interpret this, is an exception to that thing in section 6, except some people don't interpret this as an exception in section 6. Some people interpret this to say that you can store it, you can store the seed inside your module and then reuse it again inside your module, but that section 3.3 does not offer a general exception to section 6. And so there's, as I understand it, different camps that take different interpretations on whether section 3 overrides section 6 or not. Ugh, standards are hard. I feel for NIST. Writing this is tricky. So are they allowed? And there's a timeline here because in October, there was some trickle down, and I'm not trying to point fingers at NIST. I'm not trying to point fingers at CMVP, but the CMVP hierarchy is complicated. There's testing labs involved. Things get said in private emails, and some labs take that stricter than others. And some people get told one thing by their labs, and you get told other things by their labs. And then you get people who say, oh, this is not allowed. In January, NIST published an FAQ that clarified all of this. So in January, it became, there's the text of the FAQ, unambiguously clear, this is absolutely allowed. The FAQ unambiguously says this is an exception. This particular _ internal can be used externally. Awesome, we have clarity. This is allowed. The problem is there's 3 months in between those things during which legacy implementations came on the market. Cool. Uncool. So yeah, so the problem here basically summarized is that due to the uncertainty around interpretation of the FIPS, many hardware crypto modules entered the FIPS validation queue during those 3 months. And so now we're stuck with legacy MLDSA and legacy MLChem implementations that do not support seeds. And by that, I mean like both there are hardware on the market, but also there are like real keys in production protecting real important data for which the seed has been destroyed. It no longer exists. We're going to need to move those keys in 10 years to new hardware. There is no seed for them. So we have legacy stuff to support already. Woohoo! So, all right, fine. There's two formats. We're IETF. We can handle 2 formats, right? How hard can that be?
Note
So,
the smiley face.
I don't know whose GIF I pulled off. I think it's Creative Commons license, I hope, because it's just perfect. Okay, so lessons learned from labs. So what this mega, I think Deirdre counted at one point and counted to 150, and I think it didn't stop there, this long email thread. So where did it settle? Basically, the fact that NIST gave us 2 valid encodings for private keys means that protocols have to choose between supporting key only, seed only, choice, or both. This is now forwarded to protocol developers to have to figure out. Protocol developers can forward it to the implementation and forward it to the operational people and say, you figured if you export a seed from one thing and it won't import the other thing, that's your problem. That's sort of the choice one. So we could choose to punt this on, or we could choose to resolve it ourselves. At the end of the day, this is the ASN1 that LAMPS has settled on. It is all of the things. Note that this is ASN1. Note that the both is ASN1 inside the ASN1. So we've done a great job, I think. The public keys, the ciphertexts, and the signature values are non-ASN1. Those are in the FIPS. NIST gave us actual wire encodings for public key ciphertexts signatures. We did not need to wrap those in ASN1. So unlike RSA, other protocols like COSE that don't want to touch ASN1 with a 10-foot pole don't have to, that's great. We couldn't make that work for private keys. There is necessary ASN1 in here. What else did we consider and reject along the way? All of this. So we debated, can we get away with seed only? Can we get away with key only? Can we get away with both only? Can we come up with alternative OIDs? So NIST has defined OIDs. Can we say the NIST defined OID refers to for example, the expanded format, and IETF will define new OIDs for the seed format and new OIDs for the both format, is what the alternative OIDs means, or a choice or a sequence of optionals, which is subtly different than choice. And they all have pros and cons. And in these slides, I've tried to list out pros and cons, bless you. And yeah, so I'm gonna skip over the detailed pros and cons. This is here for archival purposes. If you wanna sort of see what the pros and cons of each one was, seed only, key only. I'm gonna note that key only was the runner up. At one point, Russ threatened us to behave like adults, and if not, we get key only. Which I think is correct, because if you can't agree, then you have to fall back to key only. It is the lowest common denominator. And then everyone, okay, we'll play nice. Both only, alternative OIDs, choice, sequence. And then the winner is the choice of all of the things that are above. And it doesn't have a zero cons list. Like, this is still not ideal for reasons, but I think Russ phrased it nicely. Russ did a great job of moderating, by the way. And Russ basically said, can you not live with this? And this is the only option that nobody couldn't live with. So it's what we get.
Actually,
yeah.
Go back on that one. So just, I've been through the pain of ASN1. Talk about the last bullet under cons there.
What would you like me to say about the last bullet? Under
the
cons?
fact that both really only exist in ASN1 world and not the rest of the world.
Yeah, so sorry for Jose and Koze. You're gonna have to define your own private key format. You can't have this one, I think is what that means.
That's what I'm interpreting as, that you found this was the best you could do on that.
It was, I mean, Lamps tried to give an ASN1 free, and just other priorities took priority. The ASN1 is not crazy, and I think especially Victor from OpenSSL has been proposing that you can write language in which you describe the ASN1 as some static bytes, and here they are in a table, and you can sort of forget that it's ASN1 because we can just tell you in the RFC what those bytes are going to be. And we might be able to get away with that. That text will be iterated. We'll get back to you on that. I have a bonus topic which I snuck in here, which is not related to this particular flame war, but is its own flame war, which is it's unclear if the external mu mode is allowed by NIST. There's been some great discussion. NIST posted an FAQ on external mu at the end of February, and then quickly within a couple weeks, there was a meeting that was held about whether this FAQ text actually works to does what it thinks it says it does. There's some great pictures here that I'll give Tim Hudson at OpenSSL credit for. So this is, and I won't sit on this forever because I want to give time back, but this picture shows what the FAQ currently posted allows. It allows you to split, so this is, I've switched from private keys to external mu. You can split the MLDSA signature into a pre-hash step and then a sign step. And the NIST FAQ talks about module A calling module B. So it allows this thing where you do the pre-hashing and then directly invoke the module B, but it's still sort of from the outside, one operation split over two modules. The IETF wants a picture that looks more like this, where you can compute mu and then pass it back to the application layer and then make a separate invocation to sign the mu. And it's unclear if the FAQ that NIST posted allows this. I understand that NIST has heard this complaint, not compliant, and will get back to us, and that's great. And I'm hoping that this is resolved. As I said on the last slide, I think this mode already resolves probably 80% of use cases. Like, you think of a smart card and its proprietary driver, smart card, and maybe the Windows driver is the only client that calls it. That's already nicely covered. So the 20% use cases where you want to, I don't know, compute mu and then pass it over a REST API are the sort of things that are not covered by the FAQ, and we're hoping they will be, please. Yeah, next bonus topic, what does this mean for hybrids? Both the seed only, the private key stuff, we're figuring that out. I think a lot, JP gave us an update from the hackathon. The hackathon spent a lot of time on this question over the weekend. So I think, how do we take the now big choice blob object for MLDSA and MLChem, and how do we put that into a make a hybrid key, which is not horrible. I think we have a way around that. We'll get that out in the next composites draft. So here's the summary. Again, that's what LAMP settled on. And I want to end by quoting Russ Housley. My conclusion is that no algorithm should have more than one private key format. Cryptographers need to never do that again.
We still have a few minutes for questions. Tiru?
So what happens for other protocols? Are they supposed to go with just seed approach, or this, like if we don't have any predecessor implementations available, right? I mean, you had to go with this option because it was already deployed, right? But for new protocols like COSE and JOSE, which are still figuring out, right? Can they just go with the seed approach? Or they have to go with like the choice approach that you had with?
Well, if your protocol is software only and will never have keys in any of these hardware things, sure, do whatever you want in software. If your protocol is going to use like a smart card from some vendor who's already put their smart card through FIPS and says, sorry, we didn't give you an API for seed, then you're going to have to deal with this problem.
But how do you know, like the protocols are still evolving, right? They're not yet been RFCs yet. So people have already done that. How do you know, like if COSE is already being deployed in a smart card, right? How do I know that?
I don't know that either.
By the way, this is one of my reasons why seeing both on any ASN1 just gave me the willies. It's like that just sort of makes everyone else's life almost impossible. Paul?
Yeah, just a short comment. So the COSE draft is actually waiting on my desk, and I held it there until this issue was settled so that COSE could actually support that properly, and so that we didn't have like different formats on the different protocols. So that document will now have to look at this conclusion and implement, both seed and the both construct and everything.
I will ask a question to the open air universe, which is, do private keys need to be cross-protocol compatible? Is that actually a hard requirement? I understand why it's really nice for ciphertext and public keys to be cross-protocol compatible. Are private keys as important? Or if you have to sort of transcode them, is that world-endingly bad?
Rich, you're next.
Yeah, I just want to point out, if you can go back to the definition of the choice, the thing that makes this not horrible, or as not horrible as ASN1 can be, is that everything is with a fixed size. So if you get something that is 64 plus whatever the little wrapper is, then you know what it is. If you get it as 3168 plus the little wrapper, you know what it is. I think it was Russ who first came up with that. So that's fairly clever engineering that will make it easy to sort of ignore all of the ASN1 and any of the kind of decoders. And that's, I think, what Victor was alluding to.
Deirdre?
I think you might have written this down, but we didn't get into it. We have the thing that LAMPS has settled on is something like seed or expanded key or both. But when you have both, you have a seed and an expanded key. And currently, you can correct me, the only recommendation is you should check that seed and expanded key match. The way you do this is by running, derived key, which is in FIPS 203 or 204 or whatever it is, with seed as the input, and literally doing a byte-wise comparison, which you can do in constant time if you want to, between what you get and the expanded key that's in this encoding here. But it's not a should, not a must. It's only a should at this time, which feels very bad, and a lot of us have argued against it, but that's currently what's on the table. I just wanted to voice that aloud.
Yeah, I don't know if Sean or any of the other authors are here in the room, but yeah, this is Deirdre just mentioned the unresolved point. So this is not on my slides because it has not reached conclusion. And there is another camp, and the other camp does both mean, is it another form of choice? If you're going to take the seed and rederive it anyway, can you just ignore the expanded? Is there like, I haven't seen a demonstrated attack that happen. I've heard some argument like if you have multi-layers and the first layer does input validation and the next layer doesn't, then, but I'd like to see that flushed out. So short of having this at the microphone, probably belongs at list. There's still two camps on that one.
Okay, thank you. That was super useful. Deirdre? Oh, no, don't walk away with that. Thank you. Yes. Hey. No, now I need to share slides. Oh, you gave me one revision, correct?
Yes.
Okay, I didn't do it. And wait, hang on a second. Slides, clicker, plus. Yes, hand it off to her.
Great. Okay. I'm talking about how the IETF does cryptography and how it actually, in its current state, makes IETF and IETF produced protocols quantum fragile, as in they are vulnerable to quantum attacks by a cryptographically relevant quantum computer. There we go. So anyone in this room is probably familiar that the threat is currently active to protocols that are encrypting things now, where the keys are being agreed upon by a traditional or classical cryptography, elliptic curve Diffie-Hellman, RSA. All of those things are vulnerable to store now, decrypt later attacks. You just record everything, shove it in a database, shove it in a data center somewhere in Utah, or wherever you want to put it, and just wait until you have your cryptographically relevant quantum computer come online, and you point it at the juiciest thing you recorded in your database, and you decrypt it whenever you want. So this is the live threat now. The migration deadlines, timelines, are rolling out now. 5 years before traditional asymmetric cryptography, Diffie-Hellman, RSA is deprecated, 10 years until it's completely disallowed by the US government. The BSI timelines from Germany are about the same, and more coming out like any day now. It takes on average 5 years for CFRG to bring a document to RFC. Yes, these are informational RFCs. They are not internet standards, but they are RFCs that the outside world, outside of IETF, considers a standard. It is a locked document with a number that they can point to that came out of a standards body that they say is a standard. Yes, they don't think that a stable document with a code point or a specific version or anything like that is a real standards document. They don't know what that is. That is a thing that someone threw up on the internet for all they know. And it doesn't matter how much we tell them that, oh, you can negotiate post-quantum cipher suites, you can do, X-Wing, which is currently just a draft that's not been adopted by anyone in the IETF. They don't know what that is. They can't bring it to their hardware vendors and say, let's implement this thing, because they're like, that's not a real standard. I can't implement that. That might change at any moment. So here's a case study. Mike Owensworth brought a draft in March 2023 to CFRG about hybrid chem combiners. It was not adopted. There was no call for adoption. The argument was, we are full, the CFRG is full, and we cannot take any more documents. The work started in LAMPS in 2019, is not quite done yet, still going. A co-author on X-Wing, proposed it in March 2024. It's been implemented in several places, in several languages. It's been deployed in some places on Cloudflare, and there's been lots of vocal support inside and outside of CFRG. It has not been adopted. We just asked the chairs one more time, please run an adoption call, not even like literally please adopt it, but literally do a call at all. They will not. They said no. CFRG is running their own hybrid chem combiners research area. That is just now getting off the ground. I am a co-author on that document. I'm the only author at present, but there will be other authors joining me. And that got delivered 2 months ago. The design team was assembled in early 2024, and the first draft was presented literally here at this meeting. It takes 2 years for the whole thing about hybrid chems to go from someone coming to the CFRG and saying, hey, we should do this, here's a draft, to a literal draft actually showing up that the research group adopts. 2 years. We're talking 5 years for deprecation timelines for post-quantum. Hybrid chems are not cryptographically difficult. They really are not. These are not zero knowledge proofs. They're not a whole brand new ML chem guts stuff. Hybrid chems are not very cryptographically difficult. The problem is everyone in the world has their own elliptic curves, their own RSA stuff, their own brand new post-quantum stuff, Photochem, Ntrue, MLChem, Psych back a couple of years ago, and they need to mesh them together. That is where the complexity is coming from. It's not the cryptographic complexity. We have a lot of different ways that we can put together hybrid, make a hybrid chem in a secure way. That's not an issue. Like, we know how to do that. The whole point of hybrid, especially for key agreement, is because we want to go to a PQ posture, a quantum resilient posture now, before we have fully vetted or have full trust in these brand new post-quantum primitives like MLChem or Michaelis or whatever it might be. You need to move now to get the benefit, not 10 years from now, not 5 years from now. You're supposed to be, hybrid is supposed to enable you to move faster, but I don't think we're getting there. The only org in IETF that seems to be meeting as close as possible to meeting the moment, I don't know when you say close as possible, close to meeting the speed moment is TLS working group. This is partially enabled because TLS 1.3 is a beautiful protocol that has a wonderful key schedule that makes it easy to just staple to a post-quantum shared secret and a traditional shared secret together and shove it in the key schedule. It already is taking a bunch of questions about how to do these things out because it's already doing them. But we'll get to that in a moment.
Deirdre?
Yes.
You've got 4 people in the queue already,
Uh-huh.
and you're on slide 6 of 22.
All right, I'm gonna go fast. All right.
Well, no, I'm just saying, do you want to take people now? And
No,
good, thank you.
I need to get through this or I'll never finish. In the last 5 years, CFRG has published 10 RFCs. The median time from an internet draft to a final RFC is over 5 years. The mean is over 5 years. Even solve schemes where the CFRG says, hey, we're interested in, say, threshold signatures or something like that. They go out to an established scheme. It's not a competition. That process to actually take that to an RFC took over 5 years.
Sorry, Paul Voters, AD. I want to stop you here for now for a little sec, because I don't want this to become the complain about CFRG session. That's not the task of this working group.
I got more stuff. I got more things to complain about.
So please skip over the CFRG things where you're talking about the process of IETF and working groups. If you're talking about technical stuff, I think that's okay, but try to not talk further about the process of how working groups run. I think that's not appropriate here right now.
Is it not? This is about the process of IETF and why it is not working.
It's not in charter of PQUIP.
Okay.
Basically, you can't really start here a bashing session
Where's the
about
appropriate
CFRG
venue for me to
chairs, right?
discuss this? Because I thought I could talk about it here. I would like to speak about it. I asked if I could speak at a SAG, and you said no. About this, about process, not technical.
Well, yeah, we should have talked on more offline before we bring this out in the public, I think, like this.
Okay. For many orgs, a draft document, adopted or not, is not enough to say the investment into implementation, to start investment into implementation or integration. Let's go. Yes. An RFC is not a standard. It is just an RFC. There's not a protocol police or an RFC police, but to people outside of the IETF, an RFC is what they need and not a draft internet document. Despite what people seem to want from CFRG, it is not a working group. It is a research group. In its charter, it is saying we pick up research areas and we go into them and we try to meet certain needs and try to find good options for the IETF community in terms of cryptography. And they give reviews to other working groups who come and seek reviews. But there's other topics like very specific engineering-based technical documents or specific areas that often are brought to CFRG and say, hey, like we would just like to have cryptographic expertise to standardize it. And they're like, that's not what we do. We do research here. But there's no other venue inside the IETF that really does the same thing. But the IETF doesn't really have any other cryptographic expertise unless it's a protocol by protocol basis. And so they think CFRG is going to solve their problem, and then it doesn't. And then the things that it does give them, they're not quite, it doesn't quite solve all their problems, and everyone's kind of unhappy. Yeah, this is kind of more of the same. Yes, and it just takes too long. Yeah, and when operating to their charter, they don't have enough capacity according to their own chairs. Okay, other case studies. PQUIP. I love PQUIP, but it's informational, it's guidance. I'm a co-author on hybrid signature spectrums. It is broad on guidance on how to do post-quantum stuff, how to do post-quantum signatures. It's non-normative. It does a lot of deference to CFRG, to outside bodies that are, say, we're going to go look at MLChem, FIPS document number, about pulling those in and how we use those to do PQ stuff and guidance and PQ stuff in the IETF. It's not where you bring a document and say, hey, I need this very narrow, specific cryptographic thing. I need it soon because of the PQ migration. You don't bring it to PQUIP. That's not in its charter. Independent stream, like where else can you go to get something done on the score? Independent streams, independent editor. They need to defer to this other cryptographic expertise inside the IETF. A big shrug. Like, we, the X-Wing team, we are not getting adopted in CFRG. We're talking to the independent editor. We're trying to see if that's a route for us to get it turned into an RFC so we can help the people that want to implement it and adopt it outside the IETF. We'll see. We don't know what's going to happen there. This is Paul's mention. So this is a document about how, a bunch of other things, how to do cryptography in the IETF, but also should we have RFCs for like using MLChem only in TLS, using hybrid chem thingy in, I don't know, MLS or something like that. Does that need to be an RFC? Or, as we've kind of been doing the past couple of years, just get a stable document and register a code point, especially if you need a code point. If your thing does not register a code point somewhere, like maybe you're in this kind of no man's land, go to CFRG. This document, according to my reading, is basically doubling down on that of get a code point, wait a number of more years, and then revisit it, and we'll see if we want to maybe adopt it and turn it into an RFC eventually, or maybe turn the recommended flag from no to yes, depending on your IANA registry, that sort of thing. This is counterproductive. This is for the PQ transition. This is the exact opposite of the things that the protocols and people who are trying to transition this cryptography and get it ready for quantum threat to get that done. Slowing things down further is going in the wrong direction. Okay.
You have to notice you have now 9.
Yep, and I'm trying to rush to the end. Yes, in this document, the ADs classify new primitives as the only new cryptography that they're discussing. Unfortunately, despite what people seem to think about working on the TLS protocol, or maybe the MLS protocol, or the SSH protocol, or IPsec protocol, those are all cryptography. Cryptography is not just in the primitives. It's not in MLDSA versus ECDSA. It's not in MLChem versus X25519. The whole protocol is cryptography. And some of these working groups are doing cryptography with a little bit more latitude and moving than the document that I just referenced would indicate. So why are they allowed to do cryptography, like say IPsec and even SSH and TLS and MLS, but when it comes to registering new primitives that you can't get an RFC for, or it's going to take a very, very, very long time to get an RFC for, it seems like there's this like bifurcation or severance of our brains about what is cryptography and what isn't, and that's not true. Like it's all a continuum. They're all cryptography. Yeah. Yes. This is salient right now. This is not just me coming up and complaining. Because of the lack of movement, because of the lack of documents that are actually like real standards from the outside perspective coming out of IETF, people who are deploying things in the real world have to find a solution for themselves that is completely not standards-based. It doesn't have interop because they have to deploy something now, because they have to get it out now to be compliant and to be resilient from the quantum threat. It's already happening, which is not great because we like technical standards. It feels like this attitude to cryptography in the IETF is stuck 15 years ago. There were crypto wars, there were curve wars, there was a lot of stuff like that, and people are a bit skittish about cryptography, it seems to me. We're in a different world. This is a different paradigm shift that we have never seen in cryptography. We've done migrations from SHA-1 to SHA-2. We've tried to do SHA-2 to SHA-3, and that's not succeeded. This is a completely different order of magnitude in kind and in scope. We need to change this up. The status quo will not work, and the cryptography coming out of the IETF will not be prepared for the quantum transition. They're currently not prepared, and they're hindering it. Yes, and so, what do I suggest? Let working groups adopt and proceed crypto to something approaching an RFC. Do not dissuade them. Be closer to what TLS working group is doing, which is once all the FIP standards dropped, a bunch of people came into our working group and said, hey, all of these things that were not adopted, but they all got code points, we like these. We want the working group to adopt them and turn them to RFCs. The tide turned very quickly. I think that's good. If there's consensus in the working group, let the working group have consensus and do what they have consensus to do. Consider changing the CFRG charter. Maybe. If you don't want to change the CFRG charter, let it keep doing research. Is there interest in a crypto engineering working group that is a working group? CFRG still does researchy type things. The engineering working group does like very practical like stuff. Someone mentioned it would be nice to have an internet cryptography task force. I'm not even sure what that looks like, but I thought I would mention it. Okay. Yes. I'm done. Now there's a queue, 10 people long. Thank you.
Let's hear from the AD first.
So speaking as an individual now, a bit.
Okay.
And I accidentally forgot to remove myself from the queue, or I failed to do it. So on the policy document, the idea of the document is actually to emphasize the fact that you do not need an RFC before you can do crypto. You should actually start doing this when it's still a draft. The fact that vendors want to wait for an RFC number, or they want to wait for a NIST document, or they want to wait for whatever else other guarantees they can get outside in the world, is not a problem we can solve here at the IETF. So we can just say, we can give you early code points for your draft, you should start using them and not wait on the RFC number for it.
But if I have a document that doesn't have any registries, there's nowhere to register it. Those are things that I am coming up with right now, and I don't have a place where, oh good, I got my code point, I'm good to go.
But you can still write a draft.
Yes, but
You can still reference the draft.
but that doesn't, that's me putting up a
Well,
thing on GitHub.
So to me, it seems like the vendors need to be educated that they should take drafts more seriously. And then coming back here and saying we need to change, it's a little weird to me. And what I want to say as well is that I've not been around when the first round of all this happened, when IPsec was getting designed, before TLS was there, sort of. That the enemy of making this happen was all of us. Like people always say, look, oh, the NSA was interfering with the IETF working groups and they were trying to sabotage things. No. It was us. We sabotaged ourselves because no one was willing to compromise. No one was willing to move things forward, and everybody wanted their specific crypto thing to happen. And I feel that we see a lot of that happening again. And if the cryptographers can agree and come with good things to us that we can easily put in a draft, we would be much further than we are. It's the cryptographers that are not agreeing. In my
I don't
view.
know about that because we have a queue of 4 or 5 documents in TLS working group that would be going against your recommendations in your SAG document, that the working group is like, adopt, 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 let's go. And your recommendations are against the working group consensus.
We need to work on that then, because that there's 2 Pauls who are authors of that. So,
Right.
yeah. So we have 10 minutes left. We have a queue that's longer than that. Be short, or don't be short.
We can do it.
You know, like, we're going to want to go to dinner, so the people at the end of the queue might not make it. But anyways, Nick?
Hey,
Hi.
Deirdre. I don't want to kick you when you're down here, but I don't think this presentation was constructive. I have some notes here. In fact, I think it's kind of borderline scandalous that this was accepted at an IETF group. So there's a lot to unpack, but I'll start with some blatant misrepresentations of the CFRG's work and of the consensus of people who work at the IETF. This statement that you made, despite what the rest of the IETF thinks, CFRG is a research group, not a working group, there's no evidence for that. It seems completely unfounded. And regarding the solved schemes, the Frost work was adopted as part of a plan to address the topic of threshold signatures. And the editors refused to address a major use case that was adopted as part of the work, ECDSA. And you know, the editors were focused on publishing their own scheme as an RFC, and even went as far.
You invited us.
I did, and the ECDSA
The
part.
scheme doesn't
Where
work
is
for
it?
ECDSA.
And it wasn't 5 years.
It was a different scheme.
Hold it.
3 years and a
hold
few
it.
months.
Stop.
Right?
Stop. I hear that she said things wrong. I hear that you disagree. That's not helping the PQUIP working group at this moment. I'm fine with you using the mailing list for this, but let's not take time at the mic about this, okay?
Okay, sure, I'll move on. So I outlined today CFRG process that focus on problems to solve at the IETF. It's not a vessel for people to push through their favorite constructions to satisfy industry parties who think an RFC is an RFC is an RFC. That's not what it's for. The last time that the CFRG did something like this, the chairs had to be replaced. So, yeah, I mean, this presentation it's steeped in complaints.
I agree with you, but also when there's a lot of support in the research group for a document, and it's like, no, we're doing this other thing instead. I don't know.
Right,
what
we
to
don't
do.
address. I explained this at CFRG.
Right, that's
we don't adopt
why it
documents.
feels like there is a disconnect between CFRG does do and it's chartered to do and what people also want from
So wait,
cryptography.
let's not do a hagiography of CFRG here, okay? Yeah.
Right, and I really don't think that there's evidence that everybody at the IETF thinks that that CFRG works one way and it works another. I don't think there's evidence for that. You haven't demonstrated that. Yes, the CFRG could be faster, but nothing in this presentation was constructive or helpful. And then for you, I should just caution that like single-mindedly pushing for a personal agenda in the IETF puts the whole organization at risk, and it risks damaging your relationships with other people that you work
I'm
with. It's not the
participating
IETF
in
way.
the hybrid chems CFRG
Actually,
draft
Nick-
and X-Wing and several other documents in CFRG and many other working groups. I'm trying to pursue every avenue I can to get good quantum resilient cryptography standardized and adopted by people who use IETF protocols. That is my goal. I am having a hard time doing that.
I appreciate that. And I think as an editor of an CFRG document, you have a different hat and you should be able to operate with different hats.
I'm wearing all the hats.
Stanislav?
Hi, everyone. I'll add only a few points. First of all, we were ready for this kind of discussion. And if you remember, at the beginning of the CFRG session, we tried our best to kindly remind of the process we're trying to make. So we would be happy to have the discussion on CFRG and not on PQUIP. I would like to stress that the solution of adopt X-Wing is not obvious now because there are some discussions on the mailing list. There are some criticism of X-Wing. I don't want to evaluate is it correct or incorrect criticism, but there are some discussions. And in the past, when we have some other drafts that were discussed, which were potentially vulnerable. It ended with one of the CFRG chairs not being a CFRG chair again. It was with Dragonfly, where when we had some concerns, some potential vulnerabilities, and maybe the process should have taken more time then. Now we are trying our best to hear all ideas, all statements, and give the community chance to discuss things, because community wants from us, from CFRG, some guidance. That's why we need to take our time. And of course, we are always open for any public or private discussion of how we should work better or how things should be done. But I think that the start of this discussion could be made privately or on the mailing list, but not on the PQUIP. We are always ready for discussion. We didn't hear these arguments or these criticisms on the mailing list, or even earlier today on our session when we started this discussion, maybe with some soft statements, but with our willingness to be ready to hear, maybe even to change charter. So these ideas were on the slides. And I think that we are always ready to hear you. And I am not sure that it is a right place to do this.
Thank you.
Thank you.
Hannes?
Yeah, I've been around for quite some time, and of course, I often had the impression that things are going way too slow, specifically when it comes to my documents, not so much about other documents. And in retrospect, I think like often there was a good reason for that. And so I think in this specific context, so I don't know all the details or even close. So I think it probably is a good idea to talk to the leadership, because I think this is a leadership question. It's a question about like interacting, in this case, IETF chair and maybe area directors and so on to sort some of those things out. I think it's I think that would be the best way forward to resolve these issues and to make everyone happy. Because I think we are all on the same page where like we see the pressure in all sorts of different directions, not just PQC, but all sorts of other protocols. And it's very difficult to meet all those requirements at the same time, move everything at the same speed, because we need to get all these reviews in. And I've seen the CFRG like having so many people coming and asking for all sorts of stuff, good stuff, but it just requires an enormous amount of energy for everyone. And I think that's often something we sort of glance over, but we have limited bandwidth as much as we dislike it. And it's also true for me, unfortunately. And I've heard complaints about my work in the group as well, not in this group, but luckily in the OAS working groups.
Thank you. Damien, and then we are going to run out of time, so.
I'll be quick.
Yeah.
I do a lot of work in the SSH community, and the SSH community.
Yeah.
Sorry.
Yeah.
The SSH community is quite concerned about store now, decrypt later, and has really forged ahead with deploying post-quantum cryptography. We've found it, several of us have found it quite frustrating, the process of getting that actually standardized as RFCs, despite wide industry adoption and despite a working group whose charter explicitly talks about standardizing industry practice. So I completely agree with your points about working groups being allowed to proceed with cryptography and forging ahead. I think the power of hybrid post-quantum is that we don't have to be as conservative if we trust the classical algorithms, which we've got several years of experience with now. I think there's also, I don't think you can also draw a bright line between the parts that are cryptographic and not cryptographic in a lot of these protocols, because cryptography is really so kind of baked into the core of them. Thanks.
Thank you. Rich, you get the last word.
Cool. So I have some complaints about some disagreements with what you said. You know, the industry is doing its own thing. If they're doing their own thing, then it's not going to interoperate with the things the IETF does. So I'm not sure that that's really a risk. I understand your frustration and concern. I believe it's genuine, but screaming that nobody has adopted my draft is not the way to get, please, let me finish, is not the way to get things to happen. For example, go to one of the other places that could use X-Wing or something and get those groups to adopt it, just like TLS did its own thing. Finally, the complaint about, oh, people want an RFC. For 30 plus years, the very first part of every single internet draft says, this is a draft, it's a work in progress. So you can't blame the world for wanting an RFC if for as long as the IETF has existed, we said the only thing that counts is an RFC. Now, if you want to change that, then we should figure out how to change that within the IETF.
The only thing that counts is an RFC, so you're mad at the world for wanting an RFC?
Yeah. That's what we've said. No, we have said, the IETF has said, drafts are works in progress and should not be cited, whatever the boilerplate is. Therefore, it's wrong to complain, or it's wrong to blame the world for actually believing us.
Thank you. So I'm going to put on my working group chair hat and say that this is not going to be discussed on the PQUIP mailing list. I do believe it does need to be discussed in places, but it goes way beyond the charter PQUIP. So, but thank you anyways. Yeah.
With my AD hat on, I will take this as an item to the ISG retreat that will happen in a couple of weeks, and we'll talk about it with the leadership.
Thank you. Thank you for the time.
Yeah, thank you. And as you're streaming out of the room, please do remember we are going to have discussions of drafts on the list. Sometimes our list is, in my mind, overly quiet. I would like to hear more. Thanks.